and welcome today into this video tutorial about LSP2. And in today's video we are going to look in depth at the LSP2 standard, and we're going to look at how value types, and in particular static types, are encoded using the LSP2 standard, and we will compare that to the ABI encoding format. So in this video what you will learn is, first we are going to look at the difference between ABI encoding compared to the LSP2 Standard Proposal 2, the LSP2 Standard. So we will see the difference and the similarities between both encoding format. And then we will look at static types, which are in particular byte, string, unsigned integers, fixed bytes length, addresses, and boolean. And we will give some example between ABI encoding and LSP2 encoding for both of these types. So let's get started. First of all, we have to learn that there are two types of encoding when it comes to the smart contract, and in particular the LSP smart contract. The first type of encoding is what we call ABI encoding. This is the encoding that we use for in contract interactions, meaning when a contract or an externally owned account is about to interact with another contract, it needs to encode the function that it is going to call on this contract, and it encodes the function call and the parameter using the ABI encoding format. So ABI stands for Application Binary Interface, and it's the format that defines how a contract communicate between each other, and how the apps and externally owned account interact with a contract in an Ethereum ecosystem. The second encoding format is specific to the LSP smart contract. It's how data is encoded and stored into the ERC75Y storage of an LSP smart contract. So this applies, for instance, in contracts like an LSP0 ERC75 account, a universal profile, or a digital asset like an LSP7 token or an LSP8 NFT. Because these contracts use ERC75Y under the hood as their storage layout, they have a specific way to encode data under them. And LSP2 define how this data can be stored, encoded, decoded, and interpreted. So now the first question that we have to ask ourselves is, what are the main differences between both encoding formats, and what are the similarities also between both encoding formats? So let's get started first with the difference. The first difference, as we have seen, is that the ABI is related to contract interaction. It's how message calls are encoded, and it's used for encoding message, so for communication between smart contracts. And if you are Web3 or the app developer, this is how you are used to use when you create contract interfaces or contract factories for then encoding function call in raw bytes, so that then this can be sent onto the dispatch on the network in the form of a transaction. The contract receives these raw bytes, and they understand what is the intention of this the call data, which function is being called, and the call data is then wrapped by the EVM and by the smart contract to execute the function. In comparison, LSP2 is, as we said, is for the ERC75Y storage. And so it's for developers building on LSP2 to know how they can read the data from the ERC75Y storage, decode it according to its value type, and how it can then be interpreted from raw bytes, which is the smart contract readable format, to a more human readable format. So the main difference in summary between ABI encoding and LSP2 encoding is that ABI is for the inside-out, contract-to-contract interaction, and LSP2 is for the outside-in, which is how data is stored in the contract storage. Now, what are the similarities? In terms of similarity, ABI and LSP2 have both a schema. If you're familiar with building smart contract, you will see that when you compile a smart contract in Solidity, for instance, you will generate a JSON file, the artifacts of a contract, and this JSON file is made contain the different multiple JSON objects that define all the functions of a contract. So you can see, for instance, here this is the schema of the setData function. It has two parameters specified as an input. You can see there is also a field that specifies the name, another field that specifies the output, the state mutability of the function, and what the type of the object from the contract. For instance, if this schema defines a function, if it defines an error, or if it defines an event. So the ABI, as you can see, also have a schema with properties that are the same for regardless of what the function is. Inputs, the name of a function, outputs, state mutability, and the type of the object. And similarly, LSP2 for the data inside the ERC725Y storage has also a schema where you have the raw data key, which is the bytes32 data key that the contract can understand, where data is stored under the hood, the name of the data key, which is the human readable format of the human readable representation of the data key. So here in this case, this data key represent basically a data key to store your profile info. This is just an example. This is not a standard data key, and same, this is not a standard data key. It's just used as example here. And here's the same. It's a data key that stores your assets. You also have like a property in the same way as you have property in the ABI schema. Here the property is one of the properties, the key type, what type of key this represents. Then you have property about the content, the data stored inside this data key. For instance, if the raw bytes represent a string, or if it represent an address, and the value content is how you can then interpret these bytes. So the value type is for encoding and decoding. It's for contract and interfaces and application. And the value content is also for application, but it's more for how you can understand this piece of data after retrieving from the storage. So now we're gonna look into, now that we have seen the difference and the similarities between ABI and the LSP2 encoding, we are going to look at static types. And we're going to see that there are differences into how static types. So static types means any type that are not arrays, with the exception of bytes and string, that are also arrays but have a bit of a different place in LSP2. We're going to see how static types are encoded with ABI format, encoding format, compared to the LSP2 encoding format. So first of all, the main difference for static types, if you compare both ABI and LSP2, is the following. The ABI encoding format always, for any static type, regardless of how long they are, if it's a small unsigned integer like a uint8 or a big unsigned integer like a uint256, when you ABI encode a static type, it will always pad to 32 bytes. For bytes and string, it's always going to add two 32 bytes long words for the offset and the length. And finally, you're going to have some form of padding with ABI encoding. And the padding will occur either on the left or on the right, depending on the type. For example, for unsigned integer, you will have a padding on the left, and for fixed size bytes, like bytes 8, byte 16, or bytes 32, you will have the 0 padding on the right. Now, for the main difference with LSP2 in comparison is pretty straightforward. The first two rules with LSP2 encoding are lifted, meaning LSP2, when it encodes data, it never pads to 32 bytes long, and it never adds offset or length to bytesN string, meaning that the data, when it's stored into the ERC725Y storage using LSP2, it's always going to be stored and encoded as it is, with the same length as defined per its type. As an example, if you and we're gonna see in practice in the next slide, if you encode an address with LSP2 encoding, it's gonna encode 20 bytes. It's not gonna add any 0 padding on the left, compared to the ABI encoding, which, as we saw, is gonna add padding, and is gonna add 12 0 bytes of padding on the left to make it a 32 bytes long word. And finally, with LSP2 encoding, depending on the type and the value, it can possibly add some padding if the type is larger than the actual value. As a simple example, if you encode with LSP2 the number 5 as uint, let's say uint32, is gonna put the number 5 and is gonna pad with some 0 on the left. It's gonna add 3 bytes on the 30 bytes on the left. Okay, now let's look at, we're gonna have a walkthrough through all the type, the specific static type, and we're going to compare ABI encoding versus LSP2 encoding. You can head over to the official Solidity documentation under this link, and you will learn all the detail of what the ABI encoding format is for any Solidity type. And you will see the first sentence that defines the ABI, that it's the standard way, the encoding format used for encoding contract interaction. So, as we have seen in this video, we are not going to look at dynamic types, meaning any types that are arrays, except for bytes and string, which have a specific case in a specific place in LSP2. We will just look at static types, meaning types that are static at compile time, that we know have a specific length. Okay, so we will use the definition of the ABI encoding for each type, where we will use the value x as a value for a specific type, and the encoding function encode, enc here, and we will see how this encoding function is built for the ABI encoding, and in comparison how it's done for the LSP2 encoding. And we will look at all these types. So let's first start with the bytes type, which is a byte string of length k, which we will define that the encoding function for that is basically 2 words. We'll see there's actually 3 words. It's the number of byte encoding as uint256 string, and follow that by the actual value. And both of these words are 32 bytes long. And let's look at the example. We have data to encode cafe, food, which is 8 bytes long. With the ABI encoding format, we will have the following format. First, we will have a 32 bytes long word to specify the offset, which means it's where the data starts, the index in the byte string where the data starts. Then we will have a second bytes word which specifies the length, meaning the number of bytes that the data contain, and then the actual data. So if, to understand the offset, if you will lay down the whole bytes data into a single string. Here I broke it down to make it easier to understand, but if you will lay it down into one single string, the offset or x20 here is the hexadecimal value for the number 32. So it's index 32. So if you count 1, 2, 3, 4, 5, etc., until 32, you will see that it starts here. So it's basically the index, the offset in the data string where the data actually starts. So the first thing to understand for the ABI encoding for bytes type is that it's always offset plus length plus the actual data, and also what is important to note is that bytes is always write padded. In comparison with LSP2 encoding, the encoding for static type is different. It's simply the actual data as X byte without any padding. So it's the data as it is. There's no 32 bytes word for offset, there's no bytes word for the length, it's just the plain data as bytes, as arbitrary byte as it is. Okay, now let's look at the second type, which is string. A string is the same as a byte, except that every single byte in the data, it's the UTF-8 encoded an UTF-8 encoded character in hexadecimal. So as an example, when we encode the data hello Luxo, the first byte for OX48 is the UTF-8 character for the capital H letter. The second byte OX65 is the UTF-8 encoded character for the lowercase e, and etc. So the ABI encoding format for string works the same as bytes. You have a first 32 bytes word for the offset, then a second 32 bytes word for the length. So the offset where the data starts. The length here is 11. It's OXOB, 0 left padded. So OXOB is 11, the number 11 in hexadecimal, meaning there is 11 characters in the string, including the space. The space is also considered as a character. And then the actual data, the UTF-8 hex bytes represented, that represent each character. And the same as bytes, it's always write padded. So if we compare with the LSP2 encoding, it's the main difference. The difference is the same. It's the same case as bytes as we had before. It's simply the UTF-8 hex bytes for each character, and there is no padding. So the data as it is. Okay, now let's look at the next type. We are now going to look at unsigned integer. So an unsigned integer, according to the ABI encoding format, it's the beginning encoding of the value x, padded on the high order left side with 0 bytes, so that the length is 32 bytes. What does that mean? Let's take an example where we use the number 42 as a uint, and we use the type uint256, so 256. So m is the number of bits. Here, the ABI encoding format is it's basically the number in hexadecimal. So 42 in hexadecimal is 2a, and it's a beginning representation, meaning that the high order bits are, so here we are looking at the number in bytes, but under the hood is always it's only going to be bits. The high order bits are on the left side, meaning that the big part of a number is on the left and the small part of the number is on the right. So it's always left padded to fit 32 bytes. So now let's look at LSP2. How you would encode LSP2, this number in LSP2, here is going to be the same. But it's going to be the same only because the fact that it's a uint256 is gonna fall into the same circumstances as ABI. What does that mean? That means that with the LSP2 encoding, when you encode a uint256, you encode the number as first a hex value. A hex value that is the same number of bytes as the type suggests. So here 256 bits is equivalent to 32 bytes, so it's going to be encoded as 32 bytes long. Second, it's going to be left padded with 0, the same as ABI encoded. It's going to be the padded on the high order bits on the left side, and it's going to be encoded to fill n bytes here, where n basically specifies the number of bits. So to understand the difference, let's look at a smaller unsigned integer type. Here, let's use the same example, 42, but as uint32. If you look at the ABI encoding format, it says it's going to always be padded on the left side to fit 32 bytes. So it's always going to be padded to fit 32 bytes with ABI encoding. So either if it's a uint32, a uint64, or a uint256, it's going to be left padded. Now, if you look at the LSP2 encoding in comparison, it's just going to be padded with the same number of bytes equivalent to the bits specified in the type. So here's going to be padded with 8 bytes. It's going to be left padded with 0, always on the left, and to fill the number of bits specified. So here uint64 correspond to 64 bits correspond to 8 bytes, so it's going to be padded on the left side by 8 bytes. Now let's look at another example with a fixed size bytes value, bytesM. So according to the ABI encoding format, bytesM is a sequence of bytes in X that's padded with trailing 0 bytes to a length of 32 bytes. Trailing 0 bytes means that the 0 bytes are on the right side. Let's look at an example. Here with this value, which is basically 1, 2, 3, which is 4 bytes long. If we encode that as a 32 bytes long value, with ABI encoding, the data is going to be on the left, it's going to be padded on the right side to fit 32 bytes. And with LSP2 encoding, here it's going to be the same, except it's going to be the same only because it fits the same the definition is going to end up encoding into the same format. It's going to be encoded as 32 bytes long value. It's going to be right padded with 0 to fill the n byte, where n here is 32. So let's do the same as we did for unsigned integer with a smaller bytes value. If we encode the same value as bytesN, the ABI encoding format, as specified, is always going to be padded with trailing 0 bytes to fit 32 bytes long. So it's always right padded to fit 32 bytes. With LSP2 encoding, what differs is that it's not going to be encoded to fit 32 bytes long value, but it's just going to be encoded to fit the number of bytes specified by the type. So here's going to be encoded to be padded up to 10 bytes. The similarity is going to be right padded with 0 on the right side, and as I said, it's going to be padded to fill n bytes, where n is the number of bytes specified in the type. Okay, now that we have looked at bytes, string, unsigned integer, and bytes data of fixed size, we are now going to look at the type address. So if we look at the ABI specification, we can see that the encoding format for address is the same as the unsigned integer of 160 byte case. What does that mean? If we take the example of this address, that as this is the data that we want to encode as an address type, if we look at the ABI encoding format, that means that it's going to encode it as an unsigned integer of 160 bits. It's going to left pad it on the left side, and so that it always fits 32 bytes. The difference with the LSP2 encoding is that there is no such padding for addresses. It's simply the address as it is, 20 bytes long, and also importantly, it's always going to be stored under the hood as lowercase. It's not checksum. Why? Because in the contract storage there is no concept of uppercase letters. It's just everything is hexadecimal, everything is lowercase. But if you use one or tools like ERC725JS, when you are retrieving the data from the storage and you decode it as a type address, it's going to checksum the address for you to make it easier and more convenient. Let's now look at the final type, a boolean. If we look at the specification of ABI, a boolean is encoded in the same case as an unsigned integer of 8 bits long, where the number 1 is used for the boolean value true, and the number 0 is used for the boolean value false. If we look at a basic example of encoding true as a boolean, with ABI encoding, it's always going to encode it so that it fits 32 bytes and it's left padded on the left side with 0. Why is it 32 bytes long and left padded? Because as we saw, it's the same case as an unsigned integer. And the ABI encoding format, as we have seen previously, for unsigned integer, regardless of how many bits are specified in the type, it's always going to be left padded to fit 32 bits, and left padded on the high order bits, meaning on the left side. In the case of LSP2, it's going to be different. A boolean is simply encoded as a 1 byte long value, where 0x01 is going to be used for true and 0x00 is going to be used for false. And if you are using ERC725JS, you can specify either the value type as bool or as boolean. Usually, because if you are coming from Solidity, the name of the type is bool, but if you are coming from a JavaScript or TypeScript background, the name of the type for boolean value is written as a boolean. So you can specify both in the schemas if you are using or ERC725JS tool. So it's more convenient for the app developers. You can use either one or the other, whichever you prefer. And if you're interested to learn more about the encoding of LSP2 for static types, you can look at the ERC725JS repo, either on this issue number with all the detail or on this pulled request. And any feedback are welcome, and any discussion around the static type are welcome. And I hope you enjoyed this video about the LSP2 encoding for static types. And if you have any more questions, feel free to join the Luxo Discord server and ask your question in one of the following developer channel. I hope you enjoyed this video. Thank you very much.